So we have some rules for how we add up various summations. So the first one I have is the sum as k goes from 1 to n of c, which would be c plus c plus c plus c n times. So I hope it's obvious that that's just going to be c times n. The second example, sum as k goes from 1 to n of k. Well, if k is 1, it's 1 plus, now k bumps up to 2, now k bumps up to 3, k bumps up to 4 plus dot, dot, dot plus n. So that whole thing would equal what? We're saying that is n times n plus 1 over 2. My next example is the sum as k goes from 1 to n of k squared. K is 1, 1 squared, plus k is 2, 2 squared, plus k is 3, 3 squared, plus dot, 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 plus k is n, n squared. And we're saying that is going to equal n times n plus 1 times 2n plus 1 over 6. And our last one is the sum as k goes from 1 to n of k cubed. If k is 1, 1 cubed, k is 2, 2 cubed, 3 cubed, 4 cubed plus dot, dot, dot plus n cubed, that's going to equal n times n plus 1 over 2 all squared. So these are useful formulas for us to have, so we're going to use some of these to answer the following questions. So the first one I have here is the sum as k goes from 1 to 20 of 3, which is 3 plus 3 plus 3 plus 3, 20 times. So I hope it's obvious that that's 20 times 3. Our rule here is what? Our rule is c times n. Our constant is 3. Our total is 20. So 3 times 20 is 60. So that looks good. Our next example is the sum as k goes from 1 to n of 5, which is 5 plus 5 plus 5 plus 5 n times, right? So again, 5 is there n times, that's 5n. But again, we also have our rule here. Our rule says the sum as k goes from 1 to n of a constant is that constant times n. The constant is 5 times n, so 5n, 5n, that matches. Now this last one's a little different. We have the sum as k goes from 1 to n of 50, which would be 3 times 1 plus 3 times 2 plus 3 times 3 plus dot, dot, dot plus 3 times 50. Now we want to use these rules. How are we going to use these rules? Well, here's the process. You can pull the constant multiplier out in front. So what I'm going to do is we're going to look at the sum as k goes from 1 to 50 of 3k. The 3 multiplies each one of those pieces, so we can, in essence, factor it out and say this is the same as 3 times the sum as k goes from 1 to 50 of k. But now what was our rule, right? The sum as k goes from 1 to n of k is n times n plus 1 over 2. So in our example up here, the n is 50. So we're going to get 3 times n plus 1. N is 50 times 50 plus 1 over 2. So we get 3 times 50 times 51 over 2. And what is that going to give us? 3 times 50 times 51 divided by 2 gives us 3825. Now let's check that using the summation notation on the graphing calculator. So sum as k goes from 1 to 50 of 3k. So math button, 0, summation, as k goes from 1 to 50, k equals 1 to 50 of what? Of 3k. And we hope we get 3825. Let's see what it gives us. Indeed, 3825. Okay, our next example is the sum as k goes from 1 to 12 of 2k plus 4. So the sum of this sum is the sum of the first piece plus the sum of the second piece. So I can rethink of this as the sum as k goes from 1 to 12 of 2k plus the sum as k goes from 1 to 12 of 4. the 2 can be pulled out in front, 2 times the sum as k goes from 1 to 12 of k, plus the sum as k goes from 1 to 12 of 4. Now the sum as k goes from 1 to 12 of 4, sum as k goes from 1 to 12 of 4, just means 4 plus 4 plus 4 12 times, right? So I hope that's obvious. That's 12 times 4, or 48. We also have our rule. Yes. Our rule tells us that the sum of as k goes from 1 to n of c is c times n. 4 times 12 is 48. So this piece is 48. What about the sum as k goes from 1 to 12 of k? What's our rule? Our rule is the sum as k goes from 1 to n of k is n times n plus 1 over 2. But I have a k of 12 here, so replace k with 12. Sum as, n with 12. K goes from 1 to 12 of k would be 12 times 12 plus 1 over 2. 12 times 13 over 2 gives us 78. So the sum as k goes from 1 to 12 of k is 78, so I have 2 times 78 plus 48. What is that going to give me? 2 times 78 plus 48 is 204. Now let's check that on the graphing calculator and see what we get. So we're going to go to math, 0, summation. K goes from 1 to 12. K, it's in alpha mode already. K goes from 1 to 12 of 2k plus 4 to alpha k plus 4. We hope we get 204. Let's see if we do. Looks good. So our next example is the sum as k goes from 1 to 10 of 2k squared minus 4k plus 7. We're going to break this up into 3 sums. Sum as k goes from 1 to 10 of 2k squared minus sum as k goes from 1 to 10 of 4k plus the sum as k goes from 1 to 10 of 7. Then we'll pull the constant multipliers out in front. 2 times the sum as k goes from 1 to 10 of k squared minus 4 times the sum as k goes from 1 to 10 of k plus the sum as k goes from 1 to 10 of 7. Now, what do we know? The simplest one is the sum as k goes from 1 to 10 of 7. Sum as k goes from 1 to 10 of 7 is 7 plus 10 times, right? So it's just 10 times 7, which is 70. So we get that third piece relatively easy. The sum as k goes from 1 to 10 of k, let's remind ourselves of the rule. The sum as k goes from 1 to n of k is n times n plus 1 over 2. So let's replace the n's with 10s. The sum as k goes from 1 to 10 of k would be 10 times 10 plus 1 times 11 over 2, which is how much? 10 times 11 over 2, I believe, is 55. So we get that piece. And then we also need the sum as k goes from 1 to 10 of k squared. What do we have there? Sum as k goes from 1 to n of k squared equals n times n plus 1 times 2n plus 1 all over 6, except we're going to replace the n with 10. So the sum as k goes from 1 to 10 of k squared would be 10 times 10 plus 1 times 2 times 10 plus 1 all over 6, which is 10 times 11 times 2 times 10 is 20 plus 1 is 21 over 6. 10 times 11 times 21 over 6. 10 times 11 times 21 divided by 6 is 385. So now we can go ahead and make all of our substitutions. We have 2 times. The sum as k goes from 1 to 10 of k squared, we said was 385. Minus 4 times the sum as k goes from 1 to 10 of k, we said was 55. Plus the sum as k goes from 1 to n of 7, 1 to 10 of 7 is just 70. So let's put all of that together. 2 times 385 minus 4 times 55 plus 70 gives me 620. And we certainly should check that on the graphing calculator and see if that's right. So let's go back to the graphing calculator and see what we have. Math, 0. Sum as k goes from 1 to 10. Sum as k goes from 1 to 10 of 2k squared minus 4k plus 7. 2 alpha k squared minus 4k plus 7 minus 4k plus 7 gives me, we hope, 620, and we have it.